Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hello, and welcome to the Digital Enterprise Society podcast. Thank you so much for choosing this podcast because we know you have a lot of different ways that you can pass your time, but we designed this show to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week for now more than 2 years with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again at the Digital Enterprise Society podcast.
Hi, Tom. It's good to hear your voice. Yeah, I every now and then take a step back and think about, I wonder what other retirees are doing, because you keep pointing out I failed at retirement. And I just, I don't think people fail at retirement. I think people find important stuff to do. And so I came across a person, I don't know her, but we're going to get to know her a little bit today, and found out that we graduated from the same program at the University of Cincinnati. So that was kind of cool. So here we go. We're going to talk to a retiree who's still doing really useful things in the world.
It is funny because I call it a pattern of circles, that throughout my life, I find people and there's some sort of a connection. You graduated from the same school, or, you know the same people, or they're the person who helped you and now you're helping them. And Craig, you have failed at retirement because you do consulting work. You said you do some board stuff. You're a podcast host. If I had come to you at General Motors like 7 years ago and said, hey, you're going to be a podcast host, would you have believed me?
No. In fact, as you know, this wasn't my idea. The people at the Digital Enterprise Society approached me and said, well, you got a good voice and you got a head on your shoulders, so maybe this will work. And I immediately said, yeah, but I need somebody like Thom to help run the thing because I haven't a clue how this all works. So here we go.
and here we go. Every single week, we're right here with really fun people to talk to. And today is going to be one of those days because every week we try to bring to all the listeners interviews and ideas that are going to help everybody enhance and grow their careers. And today we have Marsha Tuft. She is the principal at Putney Designs. And what she does is she is a retired engineer. So I don't know if she's as bad at retirement as you, but when I read her bio, I think maybe she's just as bad at retirement as you, because she is really committed to getting kids involved with STEM. She writes children's book for sort of those middle-aged kids, kind of think like, MacGyver meets Nancy Drew, sort of that age group type thing. She writes books that help get them excited about science, technology, engineering, and most especially mathematics. And on her website, she has experiments that kids and their parents can do to get them engaged with STEM. So Marsha, welcome to the Digital Enterprise Society podcast.
Hi, thanks so much for inviting me.
So before you were the queen of STEM and getting kids involved with this, give us a little background about your career, where you started off as an engineer, and then what led you to doing what you're doing now.
Well, I got my bachelor's in mechanical engineering from Purdue and signed on to GE Aviation in Cincinnati, Ohio. So I worked there for about 35 years before retiring in 2016. And GE has a huge volunteer presence. So I've volunteered with different after-school activities over the years, but the one that I really got engaged with towards the end was the Girl Scouts Year of the Girl program. They had an after-school program with some of the local elementary schools where they would meet for like 6 weeks for like an hour and a half or so each week, leading a different STEM experiment. So we had 4 different engineers working with a group of like 10 to 12 girls, and we each led a different experiment each week. And the Girl Scouts kind of picked the experiments. But the first one they did was catapults, and being mechanical engineer background, aerospace masters, materials Ph.D., but that just really got my excitement. I had to go home and I had to figure out all the physics about how to predict how far these projectiles were going to go. So that kind of hooked me. And then the next summer they they'd been having summer camp, but they added STEM experiments to the summer camp. So I was actually involved with designing an experiment for one of the days of summer camp. So we do 5 different experiments during the week, and we have 3 different weeks. And I just totally enjoyed engaging with the kids, especially 4th through 6th graders is my favorite. Summer camp, we did everything from K through 8. So you had a wide range of kids. But when I look back on my own career, sophomore year at Purdue, I ran into a snafu where I got my first D ever in physics, electricity and magnetism. And I had to think, holy crap, do I have what it takes to stick out, to stick it out in engineering? And I'd never failed before. And when the rubber hit the road, it wasn't the awards my high school physics project won. It was all the crazy stuff I was doing as a kid, creating, designing, inventing, everything from sewing to these architectural plans for my dream house that always included an indoor Olympic-sized swimming pool. But all those things, because you get in the habit of creating and designing and learning through failure, it builds resilience. You learn how to learn. You learn how to solve problems. And when the really tough problems get thrown at you, I had the confidence to say, hey, I know I'm creative. I can figure this out. Mm-hmm. And that's what makes me so passionate about getting kids engaged in STEM at an early age, before they get so distracted with junior high and the extracurricular clubs that, to me, problem solving is all about getting into your own head and figuring it out. It's not just a leader-led activity.
So Marsha, this is fabulous. I could just listen to you talk. So science, technology, engineering, math, it's been quite certainly popular the last 2 decades. Can you summarize for us where is it really working? And you just sort of already answered in talking about which age group to go after. You get them before they get into high school, right? But I wondered if you have any other insights for us. What really works well?
Well, I think the youngest you can get them, the better. Mm-hmm. But personally, I feel like they're so, well, first of all, I grew up, I had a stay-at-home mom. So, I'm in my early 60s. So life was different then, mm-hmm. I had my summers off. I could play, I could paint something. I could design something. I could, I could go in the woods and catch butterflies. There were so many things that I could do. My time was not structured. I could come up with my own projects. And I learned so much from the project mm-hmm. planning and learning and making, even sewing, the industrial engineering. You figure out, okay, how am I going to lay out my workstation so that my ripper is close to my sewing machine, my scissors are close to that. So you learn things about project management and industrial engineering when you're doing hobbies as your own. But Dad always did different science experiments with me, and I would watch him woodworking. So I picked up a lot from watching him. So I think some of the cool things that they really have going in Cincinnati, we have the Greater Cincinnati STEM Collaborative. So they've got a bicycle club that they're going into local schools and teaching them how to, put together a bike and redesign it. There's also after-school activities. There's 3D printer clubs. But I think the more that we can get kids exposed to different projects, but connect with an interest that they feel like, I'm going to go home and I'm going to do something with this, that's where I think the real power is. And that's sometimes a little bit hard to spark with the leader-led activity. That's a really good point, that the common trait of an innovator or a problem solver even is a curiosity, right? A natural curiosity. Your example on your website of a butterfly metamorphosizing into a thing of flight, right? How the heck did it fit in that small package and then unfold its wings and take flight, right? It's kind of an interesting thing. And anything about flight, that butterflies and birds are really light. Well, it wasn't that light when it was a caterpillar. It was actually kind of heavy and funky, right? So it's just interesting to have that curiosity. And I think that is the key to
any kid, right? If they, assuming they're not really poor or they have other challenges, but if they have the time to just be curious, and then an adult to or even an older sibling that can just help them satisfy their curiosity, amazing things will happen. So in your life, your career, when did you know you really wanted to help those other kids? I mean, you had a positive insights in your childhood and upbringing. Did you always have? I mean, GE is really good at community engagement. General Motors was pretty good as well. But would you have done it anyways? I mean, what was the catalyst?
Well, so I had a friend who was leading up this, the Girl Scouts Year of the Girl program from the GE volunteer side. Mm-hmm. And they had like a volunteer fair where we could go and see what sorts of things GE was sponsoring, where they needed volunteer help with. And so I got to see a lot of different things. And that age group just really resonated with me. And then when I retired, I reached out to Ted Fowler from UC's Teachers College when I had a 3-year stint as manager of technical education programs, where I kind of helped to overhaul GE's advanced course in engineering at Evendale. And mm-hmm. your professors have, once you get out of high school, the professors don't have to know how to teach. They just have to be technical content experts. And what I
that's a good piece of insight.
What I learned was we can be so much more effective if we learn some basic education strategies. So based on connecting with the Girl Scouts and kind of, my passion for STEM and my gratitude for everything that I felt like I got out of, having a 35-year engineering career. Mm-hmm. I reached out to him to figure out how else I could connect in the community.
Okay. So when in doubt, ask the friends, right? Okay. Mm-hmm. Interesting. Now your background, and this is a part of engineering that really good companies that have been around for a long time, we all do this one way or another, but you were responsible for life cycle models, understanding how a part might fail, right? And you were sharing with me earlier some history about surprises along the way. A lot of people are talking more and more about being able to measure more things, whether they measure them in the field with a customer using a product or measure them through some other thing like a vibration that's occurring that you can't really explain, and especially in a rotating machine like what you worked on. If you got a vibration you're not expecting, there's a problem. You should go find out what it is before it fails. But can you tell us about in your career, how did life cycle models improve? How were you able to improve predictions, and what surprised you the most about that? It's not just about simulation, I assume. It's got to be more than that.
Well, so I worked with what we call critical rotating parts, which are sometimes, the very high energy parts, like the big rotating turbine discs that support the blades. So mm-hmm. for an aircraft engine, you start with a cycle model that figures out what the pressures and temperatures, how much you need to compress the air, how much fuel you need to inject, how much thrust you're going to extract out of that. And then they figure out how to do the aero piece to turn the airflow to get those pressures, temperatures, and other flow path characteristics. And then you've got this hardware that its whole job is to support that, rotate, support the engine, provide the structure that allows it to do its job. And when you get the speeds we're talking about and the really high energy, a failure can be loss of aircraft, loss of life. So, and the holy grail is always chasing higher temperatures and higher pressures to get better specific fuel consumption. Mm-hmm. So, you're always pushing technology, pushing the materials. And what you find out is that you're extrapolating beyond your experience, and new materials don't always behave the same way as the old ones. So instead of just having a low cycle fatigue failure mode, you might get a creep, a hold time, low cycle fatigue interaction. So now that you're more sensitive to maybe inclusions that might be in the part, because now you're making with powder metals, because you can't do with traditional metallurgy mm-hmm. to get the high changes in your matrix to support these higher temperatures. So the question is always kind of like, how do you know what you don't know? And the first step is that you need to be able to do material testing under similar conditions, and have confidence that, okay, I can calculate, here's the different stresses this part is going to see. Here's the different temperatures and pressures, so that you've got an analytical model that measures this and, what the part is seeing. And then you need to have the materials curves appropriate that you can go in and say, okay, how much life do I have at this condition? But as I said, okay, there's one type of modeling method for low cycle fatigue, which doesn't matter how long you're dwelling at any condition. But some of these alloys, as you're pushing temperatures and pressures, the duration of that hold becomes important. And then you have to get testing done at hold times. And so you can't do a hold time easily, inexpensively for like a 12-hour flight. So then you start figuring out, what can I test and how can I extrapolate this and how can I model this? And then the other piece is representing the part, so you've got this complex geometry, you've got fillets, you've got bolt holes, you've got mismatches in your web because of where they need to bring one tool in and then they need to change it.
Right. Assembly constraints, right.
Well, manufacturing, where it's just, here's a mismatch in geometry because of how they had to machine it. So that they're bringing a milling tool in from one direction, and now they have to change that to get through the thin web section and go to the fillet. So then we figured out, okay, what are the tolerances that we need to calculate? Can we calculate the worst KT that we might need in this area, and then build that into our models so that we can account for the actual processing of the part and still have confidence it's going to meet its life. So then you get a little bit where you need to understand your prints, and the design engineer needs to understand the manufacturing process enough to make sure that all those mismatches are accounted for, and things like inertia welds, where you're changing the material or you have a different forging at one part.
So I liked your point about you know what you don't know, so that you can go figure out what you need to do to fix that. And one other example you mentioned earlier as well was this point about also know your supply chain, where your raw material comes from, and how whoever you've hired, how they handle it. And the car guys and the aerospace guys, we compared notes a lot. In fact, I visited your facility many times when we were talking about new simulation methods, and it was always interesting. You guys were talking in terms of a few dozen engines, and we were talking in terms of a few million engines, but we were both going after the same thing. What is it we don't know? We were worried about efficiencies in lubrication and getting really good at that. You and I could probably debate all day, but an internal combustion engine is more complicated than a turbine because of all the moving mass in different directions. However, it doesn't have to last near as long, and the side effect is you pull over to the side of the road, you don't have to go anywhere, right? If the engine fails in the sky, that's a little more dramatic. So I like it. You got to know what you don't know. So bring this back to our kids, right? Are there some examples similar to that help inspire them along their STEM journey? It's this notion of they don't know what they don't know, so you got to go find out? So
I think with kids, there's a couple of different things. So one is exposing them to stuff that they might not know they would enjoy until they try it.
Okay.
But giving them the opportunity to own it and really internalize it and create with it, so that they come back with, okay, hey, I made something. I built something with my hands. I think everybody is a natural born, wants to create something. I mean, I think that's something
interesting
that's kind of built in, that you feel really cool when you've done something for the first time. You've created something unique. And whether that's a piece of artwork and you're working with a new media, or you're building a cardboard boat, or you're building, that's one of my favorite experiences. One of my favorite experiments was build a cardboard boat. And we did that for a Christmas and February party at GE. So my subsection, we were trying to figure out, budget cut, bullet train, the end of the year. So about what we could do for a team building event. And I was looking online. It's like, oh, cardboard boats, build a boat. Hey, we just moved. We have all these boxes. We can use these boxes for a boat.
And you guys don't freeze over in the winter, so you can just find some water.
And the fitness center, they'd already been approached about this. They let us use the pool for free. So got like 4 lanes in the pool, and I figured, okay, so some plastic tablecloths to waterproof the boat, some duct tape, some box covers, better box cutters, and I can do a little table to size the boats. And what's more fun for a bunch of engineers than designing a boat in an hour, then building it, and then testing it, and then racing it. Yeah. And then I expanded on that experiment, and I led that for 2 years at summer camp. And well, the thing, I got so hooked on it, we built a surf boat because some of the guys at work were talking about paddle boats. And I thought, okay, so how do we do this so that we don't sink? And so I came up with the idea to build all the volume displacement into the platform of the boat. Okay. And then a couple of guys actually surfed on the boat at the end. They couldn't sink our boat. They could torpedo us, but we won every race.
Yeah.
And when I did that for summer camp, so I actually built like an even higher tech version with cardboard that was so robust and so my dogs could go in the ocean and surf in the ocean on it. And then I had to build and design a beach cart to haul to the ocean. And then they came up with, okay, I went way overboard on this. I spent way more on waterproofing than I needed to. And I came up with a simple Lowe's green insulation foam core with a fabric cover that I made that then had D-ring attachments around the side so I could pull my dogs easily on it. And so I was doing all this stuff and taking pictures, and my husband was getting tired of me making him take pictures of the dogs surfing on the boats. But when I did the experiment for the school, the girls would literally drool at the pictures of Harry on his surf boat. And when they understood that, hey, I could design this myself. I could use this and design my own surfboard or something. I saw a lot of girls just really getting excited about, hey, this is something I could use and I could do now.
Yeah. Well, that's excellent. It's just, you touched on one other thing that's near and dear to my way of thinking, and I like the analogy of the words, and that's the topic of STEAM. Now, for those of you that aren't familiar, a lot of us in STEM have embraced arts as a way to inspire even more, and especially in a car business where it's half fashion business, right? What color do you make it, and all this other stuff. I think STEAM is one other thing. When kids, especially those that are interested in fashion or interior design or even consumer products of any sort, whether it be an appliance or be a bottle of ketchup or whatever, there's a bunch of artwork going on there. And people, when they create stuff, you mentioned earlier, even if they create a piece of artwork, and imagine that's not in a picture of a painting, but rather a thing you can hold, a thing you can interact with, a thing you can make better. I also liked your analogy there about you kept learning. You kept learning, and you made different boats with different criteria, and eventually one that could carry your favorite pet. And so that's interesting. So have you dabbled with STEAM more than STEM, or do you see that picking up? Because we were trying to make it more exciting. It's like STEM had been worn out, and maybe STEAM is the way to put some more energy back into it. So
one thing, STEAM, my life, if I were to describe it, would always be STEAM, full steam ahead, because I've always had this artistic stuff. And in fact, when I was working on my PhD, I'd work on this monarch quilt because, as you mentioned on my website, I do a lot with butterflies. When you see them, their wings expanding by 300% in 5 minutes, and then going to flight ready in 1 to 2 hours, it's like, as an engineer, I was thinking, wow, what a fantastic material spec. And then I had just started quilting. So my third quilt was this hand-piece, 36-inch wingspan monarch. And you can probably see it in the background behind me. It's also on my website under Quilt Gallery. There's also a Millennium Falcon quilt there on my quilt gallery. You might have to check that out. But for me, I was at my best when I was working on my PhD because I'd be working on these cool technical problems during the day. In the evening, I would change gears and work on my quilt. And so I'd engage the artistic right side of the brain, give my left side of the brain a break. And then I would come back refreshed the next day to the technical problems and get new insights. The other thing I think that arts are so great for kids in particular is you can still learn problem solving skills. You learn different media. You learn how to love your creations and to love yourself and learn from your failures. It's like, okay, maybe, and you can play in a low risk environment. So you can really try something wild and crazy and not feel like you're being judged on it or feeling like you failed. So I think that's what arts really can bring to the creativity problem solving piece, is that kids are less afraid of failing. They're more comfortable with expressing themselves, and teachers are more trained to encourage kids to express themselves and try new things. Where in the science, technology, engineering, math, you're kind of like, well, have you met the criteria? Did you optimize this?
Yeah. Too much engineering.
And competing more head to head. So I think the spark really starts flying when you are intrinsically driven and motivated and not afraid of failing, that you're more open to trying new things. And that's where you can have the biggest breakthrough.
Well, wow. You know, Thom, we haven't failed at retirement. We're figuring out how to inspire everybody else. This is really cool. So I should hand it back to you, but we haven't talked about her publications. Maybe you can touch on that.
Sure. So why don't you tell us really quick about the books that you've written and where people can find them?
Okay. So my pen name is MK Tuft. That's Tufft. If you visit my website, putneydesigns.com, there's a books page that lists all my books. They're available on Amazon, also through Ingram Spark, so there's links to where you can get it. As you mentioned before, I kind of describe it as Nancy Drew meets MacGyver. It's a 12-year-old girl who wants to be an artist and inventor, and she doesn't know how. So I throw all kinds of problems at her. She's got a magical iPad that comes with a magical interface that acts as a magic mentor and kind of helps her try new things. And so it's all about throwing different challenges at Putney and seeing how she comes out. So we do rapid prototyping in book 1 with something that most girls, any girl who's been a Girl Scout has made a sit-upon for camping. Okay, our old sit-upons were newspaper with oilcloth covers. And I came up with a really cool, simple, lightweight bubble wrap padding, can do it in 10 minutes kind of thing. And I did the rapid prototyping to figure out what does it really need to be. And she's using it for an art class where they go out into the field and draw. So would you like a wider space? So she gets coached into this rapid prototyping process and ends up with a totally different design than she would have done if she just looked at what do other people do as sit-upons. So, and that ends up in this kind of funny design challenge where there's the spoiled rich girl who just throws money at the solution and comes up with this expensive beach backpack chair that people take to the beach. And then, so she's coming up with these high-tech, expensive solutions, and Putney's going for low weight. And what do I really need? And so she gets an over-design at one point, and then she goes back, and then she's like, okay, but she's learning by doing. Yeah. And I know I've inspired at least one other kid I know is doing her own sit-upon design now, because she read the book and loved it. And it's like, okay, now they're going to work on a sit-upon design.
So that is awesome. As the father of 2 daughters, I wish I had these books 15 years ago. That's awesome.
I bet they'd be fine now. Right. I'm thinking about some managers that need to read these books, but never mind.
And in book 2, the other thing I really want to highlight, book 2, I tackled the math phobia head on. So the first book, I stayed out of the heavy, math, force balance kind of stuff. And book 2 is the cardboard boat race. So it's all about my favorite buoyancy experiment. And I took it in a fun direction. I channel Hitchhiker's Guide to the Galaxy, and I have a chapter that says, don't panic, math is magical. And I actually give the reader permission to doodle during the chapter. I don't care if they can follow the math. I want them to see what they can do with a simple math recipe. Interesting. I want them to see that math is cool, it's relevant, and imagine the places you can go with math. So that's the goal. And I got an amazing review from Reader's Favorite about just really being a fresh and fun plot, and not the typical medicine STEM kind of story, but it's good for you. Take your medicine. It's a fun adventure, and it teaches you something along the way.
Well, Marsha, thank you so much for joining us here on the Digital Enterprise Society podcast. This was great. Thank you. Thank you.
Thanks so much for having me. I really enjoyed coming.
Thanks, Marsha. Your retirement's perfect. Keep doing it.
Not too bad either.
That's right. So, and thank you to everybody who joined in and listened. Please come back every single week. Make sure you subscribe wherever you get your podcasts to the Digital Enterprise Society podcast, because every week Craig and I will bring you thoughts, ideas, and information in and around product lifecycle management. Hey, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go right now and check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.